Hey everyone, I'm Nikita and welcome back to our NumPy series for data science beginners. In the first video, we explored what NumPy is, why it's so powerful, and we also talked about ndarray, the n-dimensional array in NumPy. N-dimensional array. Now today, we'll take the next step and learn what dimensions actually mean. And we'll see how to create 1D, 2D, 3D arrays. We'll also see different built-in functions to create these arrays. So when I say ndarray, what do we mean by that? N stands for n, D for dimension, array. So ndarray is actually a class in NumPy, which is optimized for performance and memory. It's a class. So when I say I'm going to create an n-dimension array, I'm effectively creating an object of this ndarray class. Now, this ndarray class is faster than list. We have seen that in the previous video. So if you have not checked out the previous video, please go ahead and first check out that one. So it's faster than list and it supports advanced operations without using loop. So let's first import NumPy. Let's use an alias np. And to create the object of this ndarray class, we can use np.array function. Now this function, you can give a list or a nested list and it will convert it to array. So let's give it a list. This is a list data type. It's enclosed in square bracket. This is a list. And let's save the output in a variable. Let's just call it array 1D, one dimension. Now let's go ahead and check the type of this variable array 1D. It is a object of this ND array class of NumPy. If I go ahead and print this array, this is what I get. It's not a list, though it looks like a list. It's actually a NumPy array. So this is one dimension. So this array class supports some attributes also. One of the attributes is ndim, which stands for number of dimensions. So this will return as a number of dimensions. So this has one dimension. So maybe you can think of it as student's roll number. This one dimension is student's roll number. Or let us put student's name here. So now this 1D array has student's name. So it's a single list of student names. So that's why it's one dimension. Simple, right? But let's say I also want to have students' marks in 3 subjects. So each student marks in 3 subjects. So probably what I can do, let's say if you have to do this in Excel, you would have student names as the rows and marks as the column. So you create a table where names would be the rows, marks would be the column. So this is 2-dimensional data. So if we want to save the marks of students in 3 subjects, we have to create 2D array. How can we create 2D array? Now let's see that. Let's name our array marks. Again, I'm going to use the array np.array function. And I'll provide it with a nested list. So here I have marks of the first student, Ravi, in 3 subjects. Let's say Hindi, Maths, Science. Then I'll have marks of Aryan. And then Kea. Let's run it. Now, if we go ahead and check the data type of marks here, the marks variable, it is a ndarray, n-dimensional array. It's the object of ndarray class. If I go ahead and print marks, you can see this. So here, this is like your two-dimensional array, like a table. Rows are student names. So this one is Ravi, Aryan, and Kea. And the columns are the marks. So let's say the first one, Ravi has secured 90 marks in English, Aryan 100, and Kea 33, and so on. This may be science, so science 85, 98, and 56. Now let's say we have 3 exams in a class. So we want marks across 3 exams. So marks of these 3 students in 3 subjects across 3 exams. So now we need 3 dimensions. Which are those 3 dimensions? We will need the student's name or student information. Then the subject is the second dimension, and exam score. Now let's see how we can do. So we'll say marks, 3 exams or 3D, np.array. And again, I'll use the nested list here. Okay. So the first dimension is the student. So this is student number 1. Let's just have 2 students for now. This is student number 2. So this is our student. Here the information of the student will go in. Then the second dimension is the subject. So we have 3 subjects. So 1, 2, and 3. 3 brackets for the 3 subjects. For both the students, we have these 3 subjects. Let's say math, science, and English. Maybe this is math, this is science, and this is English. Same for below as well. It has to be same. And now how many exams do we have? We have 3 exams per subject. So the third dimension is the exam score in 3 exams. So let's say in the first exam, first person scored 20, so the second exam 30, and then 56 in math. Likewise, here also we can populate this. For the second student, same thing. Exams in science. And English. So this right here is our 3-dimensional array. Again, let's check. Yeah, this is an array. You can see this. Now, if you're given an array, it's very simple for you to know how many dimensions are in this array. You just look for the opening brackets. So here we have 3 brackets. So it's 3 dimension. In the marks here, we had 2 brackets, so 2-dimension array. And in this array 1D, we had just 1 bracket, so it was a 1-dimension array. Simple. So we have seen till 3 dimension, but you can create any number of dimensions. You can work with any number of dimensional array. And NumPy is the library which makes it really easy to work with multi-dimensional data. And it's very fast as well, as we have discussed in the previous video as well. Now that you understand what dimensions are, let's see other ways to create array, other built-in functions to create arrays quickly. So let's say you want to create an array with all zeros, and later on, once your calculation is done, you want to just fill in those zeros with some other value. For that, you have np.zeros function. And here, what input it takes the shape of the data as an input. So what does that mean? So let's say I want to create two-dimensional array, right? Of size 2 cross 3. That means first dimension, I want 2 elements. Second dimension, I want 3 elements. So I'll just say this. Let's go ahead and run it. So here you see, we are getting two-dimensional array. Why two-dimension? Because I've provided 2 values. So you have to provide this tuple here, this shape in the form of tuple. And I wanted 2 dimension. And in the first dimension, I want 2 values. So if you see here, this is value number 1. This is value number 2 in the first dimension. So this first value corresponds to first dimension. And there I'm saying I want 2 values. Maybe these correspond to the students. Student number 1, student number 2. And then in the second dimension, which is these values, I want 3 values. So here I have 3 subjects. So this is my second dimension. And I'm saying I have 3 subjects here. So I want 3 values. You can see 1, 2, 3. So first dimension is your outermost bracket. The second dimension is the one, this bracket, the inner bracket. And these are nothing but the number of items or elements you want in each dimension. Let's try with another one. Maybe I'll add 3 here again. That means I have 3 exams for all the 3 subjects. So here, this is similar to what we had here. Okay. You can just see the number of opening brackets, 3. So this is 3-dimensional. What about 1 dimension? Just put 1 value, 6. Maybe 6 students you have, and that's all you want. Yeah. So here, what we'll give in the input for the zeros, the shape. You could go ahead and check the shape also. So if you have this saved in X, this is what we have. So if you do x.endIm attribute, it will give you the number of dimensions, which is 1. If you do x.shape, it will tell you the shape. It will give you a tuple with the shape. So this is 1 dimension. So this is 6. And data type. If you want to check what are the data type of all the items in here, you have this D type. So these are all float numbers, right? There's a decimal in here. So these are float. Also, we said that these NumPy arrays are homogeneous data type. That means all the items have to be of the same data type. So if you have all strings, it should be all strings. If you have all numbers, it should be all numbers, maybe integers. If you have float, it should be all float. So you might say, okay, but what if I try to create a NumPy array with a number, right? So it's a mix. This list has mix of numbers and string. What will happen then? So then your value, the NumPy or the Python will try to typecast one of these values to a different data type so that all of these become same data type. So here, as you can see, this integer 3 has been converted to string 3. You see the quotes around 3? This is now a string. So Python would try to typecast some of the values to a different data type so that everything becomes same data type. But let's say it is not able to convert. So not everything can be converted to other data type. In that case, it will give you a error. There's another one similar to np.zeros, which is np.ones. Again, it takes shape as an input. So let's say I want to create an array with all 1 value of this shape. So 2-dimensional array 3 by 2. So 3, 1, 2, 3. First dimension, 3 values we have. Let's say they correspond to students, student number 1, 2, and 3, and these two are the two subjects. Another one we have is np.full. So it takes two values, the shape and the fill value. All the other arguments that you see here are optional, but you have to provide the shape of the array that you want to create and what value. So it will return a new array with a given shape and type filled with the fill value. Whatever value you provide, it will fill it. So let's try it out. Let's say shape I want is 2 dimension, 2 cross 2, 2 comma 2. And I want to fill it with 7, digit 7. So this is great for initializing an array with constant value. Another one we have, which is arange. This is similar to Python's range function. So this one takes three values, the start, the stop, and the step size. So stop is mandatory to give. If you don't give a start, it will take the default value of 0. Step size, it will take the default value of 1. You have to tell where you want to stop. It's similar to the range function. So let's say 1, comma 10, comma 2. So it will give me an array from 1 to 10 in the step of 2. So 1, then I move to 3, then 5 because I'm moving in step of 2. Then 7 and then 9. Another one we have is linspace. This comes really handy when you are doing plotting. So if you want to get evenly spaced numbers which are evenly spaced, a NumPy array where the numbers are evenly spaced, you can use linspace. Again, as I said, this you can use when you are doing plotting and all. So it again takes three values, the start, stop, and number of points, equally divided points between the start and stop. So if I say 0, comma 1, comma 5, what am I saying? Create 5 numbers between 0 and 1. Both 0 and 1 are inclusive. So I'm saying create 5 numbers between 0 and 1. Both 0 and 1 are inclusive. So this is what I'm getting. These are all equally spaced, as you can see. 0.25 is the distance. 0.25 minus 0 is 0.25. 0.5 minus 0.25 is again 0.25. 0.75 minus 0.5 is again 0.25. So these are all equally spaced. And we have created 5 numbers. 1, 2, 3, 4, 5. You can use len also to check the length of this array. Another one is again a very useful one. So if you want to create random numbers, you have this random module in NumPy, and in the random module, you have this rand function, which basically gives you a random number between, let's say, so you can just choose the P0 and P1. So I'll say I want random number between 0 and 1, and then you can specify your dimension. So here, this is your dimension. Okay. So if you want 3 dimension, you have to provide 3 values as an input. For dimension 1, let's say I want 2 items. Dimension 2, I want 3. Dimension 3, I want 4 items, or maybe 5 items, right? So this is 3-dimension array. I want, in the first dimension, I want 2 elements, second dimension 3, and third dimension 5. And what it will give me? It will give me random numbers between 0 and 1. Random numbers between 0 and 1. So let's run it. As you can see, this is a 3-dimensional array, 3 opening brackets here. In the first dimension, I wanted 2 items, right? So the outermost bracket is the first dimension, as I've already said. So you can see this is the first item. This is the second item, right? So 2 items. Then I'm saying that in the second dimension, which is this bracket here, this bracket, and this is the closing bracket for this one, right? I want 3 dimensions. So 1, 2, 3. Here also 1, 2, 3, right? And in the third dimension, which is this, I want 5 items. So 1, 2, 3, 4, 5. 5 items I have. Now you must be wondering, can I have, like, here I can have 4 items, and here I can have 5 items. Can I do that? No, you cannot. So that is not, all the items here in one given dimension has to have same length. So this random is super handy when it comes to machine learning, where you might want to simulate some data. Right. You can even change the data type when you are creating an array. So let's say I create an array using this array function. I provided a list. I want it to be converted to array. Now this array that would be created, just save it in a variable. This array, number of dimensions you already know is 1. You also know that the shape would be the 1 dimension. So the shape is 3 items, 3 elements you have. And then if you just check the D type, the data type of this, it is integer. Now let's say I don't want integer, I want it to be float. So I can change that as well. I can say D type. So this is an optional argument. You don't provide a value, it will just look at the data that you're providing and accordingly create an array with that data type. But if you explicitly mention that, okay, I want to create all the items should be float, it will go ahead and create an array with all float data types. So you see this is float now, and if you just print y, these are float. How do we know these are float? Because there's a decimal. So they are not integers, they are float. So that would be it for today's video. Today we have learned what dimensions are, what they really mean by you would go for 3 dimensions or 4 dimensions. We have also seen how to create these arrays using built-in functions. So we have used array function, we have used zeros, we have used ones, full, then arange, and random.rand. In the next video, we'll talk about data types in NumPy, and we'll also talk about why NumPy's data type are different from normal Python types. If you have any questions or doubts, leave them in the comment. I would love reading them and answering your questions and queries. And if you're enjoying this series, give it a like, share it with a friend, and hit subscribe. See you in the next one.